Good morning. In today's session, I am going to explain you some of the problems based on Lami'S theorem, right. So, first let us see the basic concept of Lami'S theorem. See here, actually we say when three vectors simultaneously acting on a point, keep it in equilibrium. Let us imagine this as the point O, on which three vectors or three forces P bar, Q bar, R bar are simultaneously acting, right. And the angle opposite to P bar is alpha, the angle opposite to Q bar is beta, and the angle opposite to R bar is taken as gamma. So, from triangle law of vectors, we have proved that P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. So, if you understand this formula and if you have that in your mind, this diagram in your mind, you can do any problem based on Lami'S theorem. So, let us try to solve different models on the simple concept Lami'S theorem given here. Now, look here. So, in this problem, O is at equilibrium, then the values of tensions, this is given as T1, this is given as T1, this is given as T2. So, you are supposed to find T1 and T2 if 20 Newton is acting vertically in the downward direction. See here, so first this angle is already given as 150. If this angle is 60, this angle is alternate angle 60 degrees. So, 150 plus 60, that is 210. So, this angle has to be 150 degrees again, right. So, I am redrawing that. See, this is 20 Newton force, right, and this is tension T2 and this is tension T1. This angle is given as 60 degrees and this angle is given as 150 degrees. Even if it is not mentioned in the diagram, the total angle is 360 degrees. So, the remaining angle 150 plus 60 is 210 and the remaining is 150 degrees. Actually, in this problem, even if this 150 is not given, we can find this as 150, because if this angle is 60, this angle becomes 60, total angle becomes 90 plus 60. But anyway, in the problem, it's given much simpler. So, this is 150, 60. Now, problem is done. P by sine of opposite angle 150 degrees. This is equal to T1 by sine of opposite angle sine 60. That is equal to T2 by sine of opposite angle, that is 150. If you look at these two expressions, 20 by sine 150 is T2 by sine 150, from which T2 is equal to 20 Newton. So, that is done. Now, if you look at these two expressions, 20 by sine 150 is equal to T1 by sine 60. So, sine 150 can be written as sine of 90 plus 60. Sine 90 plus 60 is cos 60. So, from this expression, 20 by cos 60 is equal to T1 by sine 60. That implies T1 is equal to 20 into sine 60 by cos 60. Sine 60 by cos 60 is tan 60, that is root 3. So, T1 is equal to 20 root 3. So, this is the problem just based on Lami'S theorem, right? Now, let us go to the next problem. Look here. So, in this, two light strings of 4 centimeters and 3 centimeters are tied to a bob of weight 500 grams. The free ends of the strings are tied to the pegs in the same horizontal line and separated by 5 centimeters. Ratio of tensions in the longer to shorter string. So, here you have to understand the problem, what is given in the problem. Two light strings of length 4 centimeters and 3 centimeters are tied to a bob. Look here, I am drawing that. This is 4 centimeter string. Let this be 3 centimeter string. See, they are connected to 2 pegs over there. Okay, so these two are separated by a horizontal line of 5 centimeters. See, two light strings of length 4 centimeter and 3 centimeter are tied to a bob of weight 500 grams. This is 500 grams. The free ends of the string, these two strings are tied to the pegs in the same horizontal level which are separated by 5 centimeters. Okay, so the ratio of tension in the longer string, let us take this tension as T1 and shorter string tension, let us take it as T2. You are supposed to find T1 by T2, ratio of tensions in the longer string to shorter string. Now, if we want to apply Lami'S theorem, see here, if this is 3, this is 4, Pythagoras triplet, that is a right angle triangle. By just looking at the values, we can say this is a right angle triangle. Now, how to solve the problem? Look here. So, if you know, if we take this as theta 1, if we take this as theta 2, then from Lami'S theorem, 500 gram weight divided by sine of its opposite angle is equal to T1 by sine of its opposite angle is taken as theta 1, that is equal to T2 by sine of its opposite angle is theta 2. So, here the challenge is you need to find out theta 1 and theta 2. Now, look at that very carefully. See here, I am redrawing that diagram. Okay, this is 3 centimeters, this is 4 centimeters, this is 90 degrees, this is 5 centimeters, right? Suppose if this is theta 1, this is alpha, let us take this as alpha, this as beta. So, from this, if you just like this, kada? This is mg here. So, if you draw a line here, this angle is alpha, this angle is beta. So, from this angle theta 1 is equal to alpha plus 90 degrees. Here we want sine theta 1. Sine theta 1 is equal to sine of 90 plus alpha. Sine 90 plus alpha is cos alpha. Just look at this diagram. Cos alpha, adjacent side by hypotenuse. For alpha, adjacent side is 3 centimeters and hypotenuse is 5 centimeters. So, sin theta 1 is 3 by 5. Okay. Similarly, we want to find out cos theta 1 or sin theta 2 also. So, theta 2 is equal to, again if you come back, this angle theta 2 will be equal to 90 plus beta. Sin theta 2 is equal to sine of 90 plus beta, that is equal to cos beta. Again look at this diagram, this is beta, this is the hypotenuse, this is the adjacent side. So, cos beta is equal to 4 by 5, cos beta is equal to 4 by 5, from which sin theta 2 is 4 by 5, sin theta 1 is look here 3 by 5. So, substituting this in this expression, 500 by sin 90 is 1, that is equal to T1 by sin theta 1 is 3 by 5, 3 by 5. So, here T1 is equal to 500 into 3 by 5. So, it is equal to 300 gram weight. 300 gram weight, that is T1. And substituting in this relation, 500 is equal to T2 by sin theta 2 is 4 by 5. On simplification, you will be getting T2 is equal to 400 gram weight. What is asked here? What is the ratio of tension in the longer to shorter? Longer tension is taken as T1, shorter tension is taken as T2. So, T1 by T2 is equal to 300 by 400, that is 3:4. That is the correct answer for that problem. So, here I am just repeating that problem. In this case, first you need to understand the problem. See, a bob is suspended by means of two strings of lengths 4 centimeters and 3 centimeters. Free ends of the strings are connected to the two pegs separated by a horizontal distance of 5 centimeter. So, 3, 4, 5, this forms a right angle triangle. So, the diagonal, that is 5 centimeters, opposite to that is the right angle here. So, this again if you want to apply Lami'S theorem, P by sin alpha is Q by sin beta is R by sin gamma. So, you have to find out the opposite angles. This is T1, opposite angle is theta 1. This is T2, opposite angle is theta 2. From that right angle triangle, we could find out sin theta 1, sin theta 2. On substitution, we could solve that problem. Right? Now, let us go to the next problem. Look here, this one. See, this one. A boy is hanging from a horizontal branch of the tree. Tension in the arms is maximum when? See here, tension in the arms. Both arms tension must be maximum. Then what should be the angle? See here, this is the weight of the boy. He is just hanging from the branch of a tree with his arms. So, here it is mentioned that tension in his arms T1 and T2, they must be equal and it must be maximum. It is very simple. The two tensions are equal to the weight when the angle between them is 120 degrees. When three equal vectors are at 120, then they keep that point in equilibrium. If you just have that concept in your mind, it is simple, right? So, angle between his arms must be equal to 120 degrees, right? So, if the angle, look here, again in the same concept, there is another question. An object is suspended from the center of a string. Okay, at what angle between the two, the tensions in the strings is infinity. That is another question given based on the same model. So, just look here. So, this angle, let us take it as theta, this angle is also equal to theta. So, this angle becomes, see, simply if this angle some alpha. So, this is W. W by sine alpha is equal to T by sine theta, right. So, T is equal to W into sine theta by something, sine alpha. So, this will be maximum when theta is 90. If this angle is 90, this angle is 90, and the total angle becomes 180, then it is like this. Okay, the angle between them is 180, then the tensions in the two portions T1 is equal to T2 is equal to infinity. This is another question. So, if you suspend an object from the string and if you want to make it horizontal, we can never make it theoretically. Practically we can make it, that's what we do, isn't it? Sometimes we take a string and to the string we attach a ring, and if you pull the string, that can be straight. But theoretically it is impossible, because when the string is horizontal, tension in both parts of the string becomes infinity with some load suspended. So, here the two separate questions are: when the boy is hanging from a tree, okay, then the tensions in his hands will be equal and maximum when the angle between his arms is 120 degrees. Then the tensions in both the arms will be equal and equal to his weight. That is maximum possible tension. That is one question. And the next question is, to a string horizontal, suppose if you take a string like this and if you suspend a body from the string, you can never pull that string horizontal theoretically, because if you stretch the string horizontally, angle between the two portions of the strings is 180 degrees, then the tension in each portion of the string is equal to infinity from this proof, right. So, I explained you these two questions. So, this is another example. You should remember this. Now, coming to this question, look here, a 10 kg weight is suspended as shown. Just find out T1 and T2. It is a simple problem after doing all the other problems, isn't it? So, look here, but the important thing is you have to find out the angles. By looking at it, you can say this angle is 90 degrees, right? And this angle is alternate angle, this is 60 degrees. And this total angle is 180, 180 minus 60, this angle is 120. And this angle is 90 degrees. So, the most important part of the problem for applying Lami'S theorem is you have to find out the angles properly. Now, the problem is simple. See here, this is 10 kg weight hanging and this is tension T1 and this is tension T2. This angle is 90 degrees. This angle is 120 degrees, this angle becomes 150 degrees. Total angle is 360, this is 60 plus 90, that is 150. So, from Lami'S theorem, 10 by sine of its opposite angle is equal to T1 by sine of its opposite angle, that is 90 degrees here. That is equal to T2 by sine of its opposite angle here is 150 degrees. So, from this what do we get? Suppose if you take this part, as sine 90 is equal to 1, T1 is equal to 10 by sine 120 is sine 90 plus 30, which is cos 30. So, this is cos 30. And we know cos 30 is a root 3 by 2. So, it is 20 by root 3 kg weight. That is the answer for T1. So, T1 20 by root 3 kg weight, there are 3 options. So, you have to find out T2 also. If there is only one option with T1 as 20 by root 3 in the exam, you can just pick up the option. But here as there are 3, you need to find out T2 also. Now, considering these two, 10 by sin 120 is cos 30, that is equal to T2 by sin 150, that is 90 plus 60, that is cos 60. So, T2 is equal to 10 into cos 60 is half, cos 30 is a root 3 by 2. This and this gets cancelled. T2 is equal to 10 by root 3. So, the answer is T1 is 20 by root 3 kg weight and T2 is 10 by root 3 kg weight. Third option is correct for that problem, right? Let us go to the next problem. Look here. A 10 kg body is suspended by a rope and it is pulled by means of a horizontal force to make 60 degrees to the vertical horizontal force. Look here. This is, let us just take it as a simple pendulum where bob mass is 10 kg. It is pulled aside through an angle 60 degrees by a horizontal force F. So, what is the horizontal force applied to pull it aside? See here, if you remember tangent law, you can directly say F is equal to mg tan theta, that is it. So, here mg is, this is given as 10 kg. So, mg is 10 kg weight and tan 60 is root 3. So, answer is 10 root 3 kg weight, 10 root 3 kg weight. That is the answer for that problem. Let us go to the next problem. Same, we have done same kind of problem already in today's class. So, let us do it again very carefully. A and B are two pegs separated by 13 centimeters. This is say peg A and this is say peg B, separated by a distance how much? 13 centimeters. This is 13 centimeters. A body of 169 kg weight is suspended by a thread of 17 centimeters connecting to A and B. This is A and this is B. The two segments are mutually perpendicular. So, this angle is given as 90 degrees and this load is given as how much? 169 kg weight. That is the problem given. The tensions in the shorter and longer parts are. So, do you remember Pythagoras? We learned Pythagoras triplets while learning the basic concepts, mathematical concepts related to physics. So, coming to the Pythagoras triplets 5, 12, 13. So, here let us take this as 5 centimeters, this as 12 centimeters and this as 13 centimeters, right. So, here just if you want to check, root of 5 square plus 12 square is 25 plus 144, root 169, that is equal to 13. So, if you have those basic concepts in mind, you can directly write these values. Now, you are supposed to find tension in the shorter and longer. Shorter is taken as T1 here, longer is taken as T2. That order is very important. While solving the problems in your objective examinations, that is very important. First, you need to underline the keywords and then, so shorter and longer. So, shorter is taken as T1, longer is taken as T2. It's now, suppose if this is alpha, this becomes 90 plus alpha. If this is beta, we take this as 90 plus beta. So, from Lami'S theorem, see here, so I am rewriting the diagram like this. See, this is 169 kg weight. This tension is T1, this tension is T2, this angle is 90 degrees. This is 90 plus alpha and this is 90 plus beta. From Lami'S theorem, it is very clear, T1 by sine of 90 plus beta, sine 90 plus beta is equal to T2 by sine of opposite angle. For T2, opposite angle is 90 plus alpha. 90 plus alpha is equal to 169 kg weight by sine of its opposite angle is 90 degrees. Now, look here. If you consider these two, T1 by sine 90 plus beta is cos beta. So, cos beta is 169 kg weight by sine 90 is 1. Again, coming to cos beta. Suppose if you complete that, this is given as 5, this is given as 12, this is given as 13, this is given as alpha and this is given as beta. So, cos beta is adjacent by hypotenuse. Adjacent by hypotenuse. So, T1 by cos beta is 12 by 13. 12 by 13, this is equal to 169. So, 13, from that T1 is equal to 12 into 13 kg weight. That is the answer. 12 13s are, very obviously it will be 156. 12 13s are 156 kg weight. So, this is going to be the answer. Anyway, let us check this. From this expression, T2 by sine 90 plus alpha is cos alpha, that is equal to 169, sine 90 is just 1. So, from this T2 is equal to 169 into cos alpha. Cos alpha is 5 adjacent by hypotenuse, that is 5 by 13. 5 by 13, 13 times 13 5s are 65. So, it is 65 kg weight. So, T1 is 156 kg weight and T2 is 65 kg weight. So, this model actually we have done two problems of same kind, right. Now, let us go to the last problem. Look here. Actually, if P is in equilibrium, it is a very simple problem. P is in equilibrium, then find out T1 by T2. So, here this total angle becomes 90 plus 30. This angle becomes 90 plus 60. And this angle is, because this is 30, this is 60, this angle is going to be 90. Okay. So, 900 by sine of its opposite angle, sine 90 is equal to T1 by sine of its opposite angle, sine 90 plus 60 is equal to T2 by sine of its opposite angle 90 plus 30. So, actually you need not find out the values of T1 and T2 because just you are supposed to find T1 by T2. So, if you consider these two, T1 by sine 90 plus 60 is cos 60, that is equal to T2 by sine 90 plus 30 is cos 30. That implies T1 by T2 is equal to cos 60 by cos 30. So, here T1 by T2 is equal to cos 60 is 1 by 2, cos 30 is root 3 by 2. So, the ratio is just 1 is to root 3, or T1 by T2 is equal to 1 by root 3. So, that is about Lami'S theorem and problems based on Lami'S theorem. In tomorrow's session, I am going to continue with some more problems based on vectors. Thank you and bye-bye.